Okay, today is November 12th. And the lesson that we're covering for today is learning about some exponents by looking at patterns and sequences. So we're going to learn something you haven't seen before. When you look at this list of numbers, you should notice towards the bottom here something you've never seen before. You see that? We have powers of 0 and negative powers down here. Something you've never seen before. Well, we're going to try to figure out what we do with that by looking at some of the things we already know. For example, 2 to the 6th power. We take a minute to calculate 2 to the 6th power. 4, 5, 6 factors of 2. You multiply that all out, you get 64. 2 to the 5th power, 5 factors of 2 is 32. 2 to the 4th is 16. 2 to the 3rd is 8. 2 to the 2nd is 4. 2 to the 1st is 2. Now in class, the students did that together, and they looked to see if they could find a pattern in that much. Well, pretty quickly, a student will recognize typically that when we go from one number to the next below it, we just divide by 2. So there's a dividing by 2 pattern here. 64 divided by 2 is 32. 32 divided by 2 gives 16. 16 divided by 2 gives 8. 8 divided by 2 gives 4. 4 divided by 2 gives us 2. So if that pattern continues, which it does, our next term we get by doing 2 divided by 2. That means that 2 to the 0 power is equal to 1. That's usually surprising to students. Kids will a lot of times assume it's going to be 0, but it's in fact 1, 2 to the 0 power. Now we can continue right on along with the pattern. If we have 1 and we keep going and we divide it by 2, that shows us that 2 to the negative 1 will actually be 1 half. And if we take 1/2 and we divide 1/2 by 2, we get 1 half divided by 2, which is the same as multiplying by a half. We get 1/4. So 2 to the negative 2 is the same as 1 over 2 squared, or 1/4. The same as 1 over 2 squared, which equals 1/4. And if we keep going and divide by 2 again, we see that we get 1/4 divided by 2, which is the same as multiplying by a half. We can see that we get 3 factors of 2 in the denominator. 2 in the 4 and another 2. So it's the same as 1 over 2 to the 3rd power, which is 1/8. And this pattern continues. After we looked at that, we went on and the partners looked at powers of 3. And together they worked through this with their partner all the way. So they started out at the top, which they knew they could do 3 to the 4th. Remember that that's 4 factors of 3. An easy way to do that computation is to pair the 3's, and you should see quickly that it's equal to 9 times 9, which is 81. 3 to the 3rd is 27. 3 to the 2nd is 9. 3 to the 1st is 3. You can see we're dividing by 3 this time, not by 2. 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. So if we continue that pattern of dividing by 3, the students quickly realize that 3 to the 0 is also 1. And if they keep going, then 3 to the negative 1 is 1 divided by 3, or 1/3. 3 to the negative 2 is 1 with 2 factors of 3 in the denominator, or 1/9. And 3 to the negative 3rd is the same as 1 with 3 factors of 3 in the denominator, or 1 to the 27th. And then we went one further to make sure that they really had it, and we looked at 4's. Partners work together to find 4 to the 4th is 256. 4 to the 3rd is 64. 4 to the second is 16. 4 to the first is 4. The pattern here this time is dividing by, that's right, 4. I always have one less factor of 4. So you can see here that 4 to the 0, 4 divided by 4 is also 1. And if we keep going, we get 1 over 4, 1 over 4 to the second, which is 116, and 1 over 4 to the third, which is 164. Let's go ahead and summarize those rules, because this is brand new to you. In the textbook, you'll typically see a to the 0 power. That means any number a raised to the 0 power. Well, we just investigated 2 to the 0 power, 3 to the 0 power, 4 to the 0 power. You should make the connection. The same thing's going to happen every time. Any number to the 0 power is equal to 1. Students were then asked to put this in their own words. What does this rule here mean? Most kids came up with something like any number with a power of 0 is always equal to 1. What about the negative exponents? Well, the rule in textbooks usually looks like this: a raised to the negative m power. Well, towards the end there, you should have seen the pattern that means the factors go down into the denominator, and this becomes 1 over a to the positive m. So if a number has a negative exponent when you're looking at it, kind of a little gimmick you can think in your mind is, well, we don't like negative exponents, so we don't like negative people, so we push them into the basement, or in this case, the denominator of the fraction, until they're positive. But that's just kind of a gimmick. You saw in the last page the pattern that established it. So let's look at a couple of numerical examples, because that looks so strange with the algebra. So let's say we have 5 raised to the negative second power. First thing you should do is you should write it with a positive exponent. Well, if it's 5 to the negative 2, that means we have 2 factors of 5 in the denominator. So we can just write it as 1 over 5 squared. And then you simplify that, and that is 1/25. The other example I want to give you is when we have a negative number raised to a power, like negative 3 raised to the negative third power. Well, here, the base number is negative 3, and the exponent's negative 3. All right, well, you want to think of first getting rid of the negative exponent. So you do that by writing the number in the denominator. You know, we have that 3 powers of it in the denominator. So it's the same as 1 over negative 3 raised to the third power. You've got to watch your signs carefully. Negative 3 to the third power means negative 3 times negative 3 times negative 3, which is a negative 27. Remember me talking about we don't like leaving negative signs down there because you lose track of them? So take one step further and rewrite it with the negative sign in the numerator. Okay? At this point, I ask the students to summarize in their own words this rule. Can you do that? I think something that was said was, take a number with a negative exponent and move it to the denominator or bottom of the fraction where it will be positive. That's about all the time we had in class, and the students were given their assignment to work on.